Our next presenter is Darcy Juday. She's a geologist with degrees in oceanography, soil science, retired from 20 years in oil exploration in the Gulf Coast. She loves to travel and learn about geology of other areas. A geologist's career can be like working a very large jigsaw puzzle. You get a new puzzle piece and then have the fun of trying to fit it into the big picture. When the opportunity arose for a 3-week geology field trip to the Antarctic Peninsula and the Scotia Sea, Darcy said no and instead went to Ogallala, Nebraska. No, I'm just kidding. Sorry, Darcy. Anyway, on a field trip to the Antarctic Peninsula and the Scotia Sea, led by experts in rocks, ice, climate, she jumped at the chance. But on this trip, she learned much more than she had bargained for. This cruise involved time travel, and the title of Darcy's presentation is Time Traveling with Antarctica.
Continents travel at a speed of 3 inches per year, and they've been floating around on currents of hot magma for 4 billion years, like bumper boats on a pond. Time travel, fun fact number 1, Antarctica roamed from the North Pole to the South Pole in only 250 million years. The bulge of the Scotia Sea is a geologist's paradise. Once the Andes ran straight from South America to Antarctica. Now there's the Drake Passage, and there are Andes fragments on South Georgia Island and the South Orkneys. How can that be? Let's take a look. Next is a quick lesson on how continents move. The molten mantle convects like a pot of boiling water. The continental and ocean crust are dragged along by the circulation. When hot mantle rises, a ridge is formed in the crust. When cool mantle sinks, a trench forms. At ridges, mantle is thrust into the gap to create new ocean crust, which cools as it's moved away from the ridge and eventually sinks down a trench at the edge of a continent and back into the mantle. It's then remelted and erupted to form new continental crust in volcanic arcs. Today, we have 7 major plates and several microplates like the Scotia Sea below South America. The green lines are mid-ocean ridges where ocean crust is created, and the red lines are trenches where crust is recycled. Near the trenches, you have earthquakes and volcanoes, and this is where mountain chains are built. So let's talk about time traveling again. When Antarctica arrived in the southern hemisphere 500 million years ago, it became the center of the Gondwana supercontinent. We know this by fossils the continent share, everything from ferns to dinosaurs. Gondwana became the southern half of the Pangaea supercontinent that stretched pole to pole. Now remember we said that trench subduction results in mountain building. That's the red line. The Gondwana Age Trench built the Andes in South America, including South Georgia Island, and it built similar mountains in Antarctica and in Australia, and it built the Antarctic Peninsula and then tacked it onto Antarctica. So let's see what those mountains look like up close. On the west side of the peninsula, in the South Shetland Islands, landslides filled that trench. They weren't subducted, but they were churned and metamorphosed to blue and green schists, which is a foliated, sparkly rock that was thrust back up to create these dramatic structures. And you can see the wildlife isn't too afraid. On the eastern Antarctic Peninsula, these volcanic arc granites were melted from subducted ocean crust, just like this diagram down here, and they forced their way to the surface as volcanoes or granite batholiths. The Andes were created this way, and so were some of the granites in Rocky Mountain National Park. There's another way to create volcanoes by trench subduction. Under the Antarctic Peninsula, so much heat was generated that the crust stretched and split and created the South Shetland Islands. The Bransfield Strait Basin formed, and then a spreading ridge that made the Deception Island volcano. It's fun to check out the Bransfield Strait on Google Earth. On the left, you can see the subducting trench, and then the South Shetland Islands that have spread away from the larger Antarctic Peninsula, and the spreading basin in between. The gold star there is Deception Island, the volcano that you can sail into its caldera. You can see it in the corner. In the Deception Island caldera, there's enough heat flow to cause the sand to steam, and the seals and the penguins hang out there to warm their tummies. Sometimes crazy humans take a dip in the water, but that water is not that warm. This last erupted in the 80s and it destroyed 2 scientific research stations. The former whaling island of South Georgia is notable for both its geology and its history. It was born in the Andes and recently ripped from the tip of South America, dragged 1,500 miles east along a transform fault zone, that's like the San Andreas, and is now on the rim of the Scotia Sea, which is the most isolated microcontinent. Today, the Scotia Sea, on the left you see the tip of South America and the former location of South Georgia, and now it's 1,500 miles east. Departing from South Georgia, the Shackleton expedition became trapped in ice off the Antarctic Peninsula. To find rescue, 6 men sailed an open boat 900 miles across the sea back to South Georgia, and this bleak beach is where Shackleton's remaining 22 men lived under 2 upturned boats for 4 long winter months, waiting for him to bring rescue and not knowing whether he'd actually made it to South Georgia. He arrived successfully after 17 days on South Georgia at King Haakon Bay. And here he began his 2-day crossing of this glacier and several others. And here's the time travel twist. If only Shackleton could have been here at the end of Gondwana times, 160 million years ago, Earth was in a greenhouse warm period. He might have found dinosaurs, but he wouldn't have found glaciers. And at that earlier time, just before Gondwana breakup, the Shackleton party could have hiked to safety. South Georgia was part of the Andes between South America and the Antarctic Peninsula, and the Falklands were still part of Africa, but the group would have had to hurry. A plume of hot mantle was developing, that's the orange spot in the middle, that would begin to stretch Gondwana apart. 40 million years ago, the Scotia Sea bubblegum bubble is being blown, and Gondwana continents are spreading and rotating. The Falklands moved west to be with South America. The Antarctic Peninsula thumb came out like a hitchhiker position and lost its tip in the Weddell Sea, and the South Atlantic opened. Today, the Scotia Sea is a hotbed of geologic activity. It has 3 subduction trenches, 2 new spreading ridges. Crust is still sliding sideways on the transform faults. Pieces of the Andes have scattered across the sea. And formation of the Scotia Sea affected the global climate by allowing a circumpolar current to form. Now, Antarctica has been traveling for more than 2 billion years from pole to pole. Next time you arrive at an exotic destination after a long journey, maybe you'll spend a little time thinking about the long journey that that place has taken in order to rendezvous with you. Thank you. Okay.
And if you do that, make sure you collect your air miles, okay? Thank you.